Hey everyone, ready to dive into some really fascinating tech with us today.
I know I am.
We're going to be unpacking a keynote called Thinking in Events, and this comes straight from a conference all about distributed systems.
Yeah, distributed systems.
Now, I know that might sound a little intimidating,
It can be a bit much.
but stick with us because this stuff really powers so many of the apps and websites that you probably use every single day.
Absolutely. I
And,
mean, it's really everywhere these days.
and what's so fascinating about this keynote in particular is how it takes this idea of events and shows how it connects things like databases
Yeah.
and the software that lets us, do things like collaborate online.
Right. It's like a whole new way of thinking about how to build those really complex systems that we rely on.
Okay, so let's break this down. Thinking in events.
Yeah, let's do it.
The speaker starts by defining what an event actually means in computing.
Okay.
And it turns out it's not as simple as you might think.
No, it's not just one thing. It's helpful to imagine it as like a spectrum.
Okay, spectrum.
On one side, you've got events that are basically just like quick notifications, something happened, and the system needs to react immediately.
Right.
So think about clicking a button on a website. The click is an event,
Okay.
but it's super fleeting, right? It
Yeah.
triggers something and then it's gone.
So it's like a fleeting thought. It's like poof, makes something happen and then disappears.
Exactly.
But then on the other side of the spectrum, we have events as persistent records.
Yes.
Like if you've got sensors that are tracking something over time, each reading is an event,
Right.
and it's all carefully stored for analysis later on.
Yeah. A perfect example is like a database tracking stock prices or maybe website traffic. Each data point is an event and it gets saved so you can look back at it later.
So like a detailed history of what the system has been up to.
Exactly.
Now things get even more interesting because some systems actually combine both of these ideas.
Yeah.
They use events both as triggers for immediate action
Right.
and as a record of what happened.
Right.
And that's where we get into stream processing.
Stream processing, it's all about handling this constant flow of data and making decisions in real time, like on the fly.
Okay.
And the perfect example of that is your Twitter feed.
Oh, yeah.
It's constantly being updated based on a stream of events like new tweets, follows, unfollows, all happening at once.
I can't even imagine like how much data Twitter has to process to give everyone their own personalized feeds and do it all in real time.
It's a crazy amount.
It's wild. And you know what? The keynote actually shows us a SQL query
Okay.
for finding tweets from people you follow.
Right.
Now, most of us have seen a SQL query before, but what's cool is it shows us that and then contrasts it with how an event-based system would handle this massive task.
And that's where you get into the difference between windowed versus non-windowed processing.
Okay, windowed versus non-windowed.
So windowed means you're looking at events within a specific time frame, so like finding the highest stock price each hour. But with Twitter, a follow from years ago still affects what you see today, so that's non-windowed processing. It takes everything into account no matter how long ago it happened.
So it all comes down to whether the timing between those events actually matters for whatever calculation you're doing.
Exactly.
Okay, now get ready to go a little deeper here because the keynote takes us into the world of databases,
Okay.
specifically something called database replication. The thing that makes sure you don't lose all your data if one server crashes.
Yeah, very important.
Well, it turns out database replication relies heavily on these event-driven principles,
It really does.
even if people don't always think of it that way.
Right.
Every action in a database, like adding a new row, updating a row, all of that can be thought of as an event.
Absolutely.
And those events had to get sent out to all the backup servers to keep them in sync.
Yeah, it's like this perfectly choreographed dance to make sure all those copies of the data are consistent.
And the keynote talks about two main ways this can happen. The first one is using logs, where every event is recorded in a very strict sequential order,
Yes. Total order, no room for error.
like a super detailed accounting ledger.
Precisely.
But then there's another way that allows for a little bit more flexibility dealing with what are called partially ordered events.
Right.
But we'll save that for a little bit later in our deep dive.
So looking forward to it.
For now, let's stick with those perfectly ordered logs and see how they lead us to something even cooler, state machine replication.
Ah, yes. State machine replication, or SMR. This is where things get really interesting.
Okay, lay it on me.
So instead of the database itself being the main focus, the events become the source of truth.
Hold on, that's kind of a mind bender. What does that actually mean?
Okay, think of it like a recipe. Every step, adding ingredients, mixing, baking, those are all events.
Okay.
If you follow the recipe exactly, applying each event in order you get your final dish, right? That's
Yeah.
your database state.
So instead of storing the current state of the dish, you're actually storing all the steps that it took to make it.
Exactly. And you know what's really cool? This is actually similar to how blockchains work.
Whoa.
Each block is like an event, and the entire blockchain is a log of all those events, and that defines the state of the whole system.
That's pretty mind-blowing.
It is.
So this SMR approach is pretty clever. The keynote mentions that designing your events well can actually give you a much clearer picture of what's happening in the system
Oh, absolutely.
than just looking at like a database entry.
Right, because for example, if you see an alert that says student X dropped class Y because of Z, that
Right.
tells you so much more
Right.
than just a change in a database table somewhere. You know, it adds context and makes it easier to understand the why behind the changes.
I see what you mean. And you can use those events to recreate the state of the database at any point in time.
Exactly.
You could even apply new logic retroactively if you wanted to.
You could.
But like any good recipe,
Hmm.
I'm guessing there's some trade-offs here too, right?
Yeah. Oh, of course, SMR can be a little bit more complex to wrap your head around than traditional databases. You know, especially if you're a developer who's used to doing things the old way,
Yeah.
and storing a huge log of all those events can get pretty expensive.
So trade-offs, indeed. It's always a balancing act. But hey, at least we don't have to worry about accidentally deleting data in this perfectly ordered world of events, right?
Well, not quite. The keynote actually touches on some of the challenges of data privacy regulations, you know, like the right to be forgotten.
Ah.
Deleting data when you have this permanent record of events can be tricky.
Right. You can't just erase something from history when it's part of like a permanent log.
Exactly.
That brings up some interesting challenges.
It does, but there are solutions being explored, like encrypting personal data so that it can't be accessed without the right key.
Oh, interesting.
So even in this event-driven world, data privacy is still something that we got to think carefully about.
Okay. Are you ready to leave this world of perfectly ordered events behind
I think so.
and explore what happens when things get a little messy?
Let's do it. All right, so we're venturing into the wild west of partially ordered events. Things get a little bit more complicated when you start thinking about systems that are spread out across different locations, maybe dealing with unreliable internet connections.
Yeah, this reminds me of trying to like edit a document on my phone when I have no signal.
Oh, yeah.
I can still make changes offline, but they don't actually show up on my other devices until I'm back online.
That's a perfect example in those situations. You know, trying to maintain a perfectly ordered log of events, it's like nearly impossible.
So how does that even work then? Does the whole system just fall apart if things are happening out of order?
Well, not necessarily.
Yeah.
So instead of total order, we can use something called causal order. Some events have to happen before others.
Yeah.
Like you said, editing a document before you can save it. But other events can happen concurrently at the same time without one needing to come before the other.
Okay. I think I'm with you so far. Some events have a clear order and others are just kind of like whenever. But how does that work? With state machine replication, doesn't that rely on a strict sequence of events?
That's the challenge. If different parts of the system process these concurrent events in different orders, they could end up with different versions of the data.
Oh, no.
It's like following the same recipe, but adding ingredients in a different order, you might end up with something completely different.
That's a recipe for disaster.
Exactly. So one approach is to use something called Lamport timestamps.
Lamport timestamp.
Basically, it's a way to impose order on events after they've been received.
So instead of like predefining the order, we're figuring it out after the fact.
Exactly. Imagine each event gets a timestamp, like a little number, and even if events happen at different locations or out of order, by comparing these timestamps, we can reconstruct the order that they should have happened in and get everyone back on the same page.
That's actually pretty clever. But wouldn't trying to reorder all those events after the fact get kind of complicated, especially if you're dealing with a ton of events?
Yeah, it can get messy merging all those events into a linear sequence using these timestamps. It can take a lot of computing power. It's a bit like trying to merge two huge to-do lists where items can be inserted anywhere.
Not fun.
Not fun at all.
And remember we were talking about those external side effects earlier, like sending an email or making a payment?
Oh, yeah, that's a great point. That's where another approach comes in called the time warp model.
Okay, time warp.
If a replica receives an event out of order, it essentially has to rewind back to the point where that event should have happened, apply the event, and then replay all the events that came after.
So it's kind of like rewinding a movie, inserting a deleted scene, and then watching the rest of the film from that point.
Precisely. But just like you can't unsend an email, Some actions can't be undone. So in those cases, you might have to get creative, maybe send a correction or find some other way to compensate for that out-of-order event.
Okay, so time warp sounds pretty powerful, but also pretty complex. Are there any other ways to handle these partially ordered events, maybe something a little bit simpler?
There is, what if instead of focusing on ordering the events themselves, we shifted our attention back to the state of the system?
Okay.
That's where conflict-free replicated data types come in, or CRDTs for short.
CRDTs, sorry, another acronym to add to our collection. What exactly are CRDTs all about?
Think about those data structures that you're probably already familiar with: sets, lists, maps.
Yeah.
CRDTs are like those, but they're designed from the ground up to handle concurrent changes really smoothly.
Okay.
They allow different parts of the system to make changes independently, and even if those changes are applied in different orders, they'll eventually converge to the same state. It's pretty neat.
Okay, I need an example. My brain is starting to feel like one of those out-of-order event logs.
All right, so imagine you've got two people editing a shared list at the same time. With CRDTs, you don't have to worry about conflicts or who made their changes first. The list will just figure it all out and make sure that both sets of edits are reflected in the final version.
So CRDTs are like self-healing data structures.
In a way, yes, and they're particularly well-suited for applications where users are directly interacting with the data, so like in collaborative text editors or drawing apps, think Google Docs or Figma. Chances are CLDTs are working behind the scenes to make that real-time collaboration so seamless.
The keynote actually mentions this prototype app called Pushpin that uses CRDTs, and this other concept called functional reactive programming. It sounds like they're really pushing the boundaries with these ideas.
Yeah, it's really cool stuff. So CRDTs can be more efficient than something like time warp because they don't require all that rewinding and replaying, but they're also a little less flexible because you're limited to the specific operations that that particular CRDT provides.
There's always a trade-off.
Yeah.
More efficiency for less flexibility.
Mm.
Yes, there's no such thing as a free lunch in distributed systems.
You got it. And the keynote really drives that point home. It wraps up by saying there's no one-size-fits-all solution when it comes to event-based systems. The best approach really depends on the specific needs of the application.
And just to keep things interesting, the keynote throws in some open research questions that are still being explored. Always good to know that there's still more to learn.
Absolutely. One of those questions is this idea of multi-version or branching workflows.
Okay.
Imagine having something like Git, but for any type of data.
Well,
You could create different branches, experiment with changes, and merge them back together later on.
now that would be a game changer. Just imagine the possibilities for things like collaborative design data analysis, even scientific research.
Exactly. Another question they raise is how to handle changes to the data model itself, especially in systems where different replicas might be running different versions of the software. Got to think about those updates.
Ah, yes. The joys of software updates.
Mhm.
That reminds me how important backward compatibility is if you want things to keep working smoothly between different versions of an app.
For sure. And last but not least, the keynote challenges us to imagine a world where these data change notifications are everywhere.
Okay.
Instead of constantly having to check for updates, you could just subscribe to streams of events and be notified instantly whenever something changes. It's kind of like having this real-time feed of everything important that's happening in your digital life.
No more hitting refresh on your inbox every 5 seconds. Send me up for that. It's like they're saying this shift from request response to this publish subscribe model could completely change how we build and interact with software. Pretty bold stuff.
It is. And to end things on a really thought-provoking note, the keynote leaves us with one final question. If everything is an event, does that change how we think about programming itself?
Whoa, that's a big question.
It really is. It makes you
Yeah.
wonder, are we on the verge of some fundamental shift in how we design and build software? Like, instead of thinking in lines of code, maybe we should be thinking about, like, weaving together these complex tapestries of events.
That is a pretty mind-blowing idea to consider.
It is. But even without going too deep down those rabbit holes, this keynote has given us a lot to think about. I mean, we've gone from those, like, quick fleeting events like clicking a button all the way to these persistent logs that record everything a system does. We talked about Twitter feeds and blockchain ledgers, and it's all through this lens of events.
It's been quite the journey.
Yeah.
I feel like we only scratched the surface, though, of what's possible with event-based systems.
Oh, yeah, for sure. There's so much more to explore, and it's a field that's constantly evolving.
Well, thanks to this deep dive, you've got a good foundation to build on.
Mm-hmm.
Who knows? Maybe one of you listening will be the one to solve those open research questions or build the next amazing app using these event-driven principles.
I hope so. The future of software is full of possibilities, and understanding these concepts is key to unlocking that potential.
So keep those event streams flowing and keep asking questions until next time. Happy coding.